Morning, everyone. If you'd kindly take a seat, please. Welcome to Solar System Exploration at 50, a symposium co-sponsored by the Space History Division of the National Air and Space Museum, the Science Mission Directorate at NASA headquarters, the Jet Propulsion Laboratory, and the NASA History Program. I'm Bill Barry, the NASA Chief Historian. And before I introduce our first speaker, I'd like, for formal welcoming remarks, there are a couple of administrative announcements that need to be made, so let's start with that. And first of all, let's start with safety. If for some reason we need to exit the room, follow the doors to your left there and exit out and follow the directions of the staff in case we need that for some reason. Secondly, courtesy of those of you who have cell phones and mobile devices, if you'd go to either quiet mode or vibrate mode, that'd be great. I'd also like to express our thanks to everybody who applied to participate in the program and the panels. We had 3 times more papers than we had room for on the panels. So that's really impressive for a 2-day symposium. The organizing committee, I think, was able to select a pretty diverse and interesting group of papers, and we think you'll really enjoy the program we have set up for you today. On lunch, those of you who pre-ordered lunches, they'll be available back where you found the coffee this morning. At lunchtime, would ask you to file out, pick up your lunch, and come back in here for our keynote lunch speaker. There's a little fold-up table there on your chair there, so you can just enjoy your lunch there. You'll have a little sticker on your security badge of a various color if you ordered your lunch. If you didn't order lunch, there are places just outside the doors. You can go grab something quick if you'd like. We're doing a live webcast today, so please keep in mind that if you're not standing up here or at the table talking, people won't hear you very well. So we have microphones and we'll have runners. So during the Q&A sessions, if you'd please make sure, before you ask your question, after you're recognized by the panel chair, make sure you have a microphone in front of you. Now, an event like this doesn't happen by itself, so I'd like to thank the organizing committee members, and in fact, I'd like to ask the organizing committee members, people from the history program staff, anybody from Xantech who's in here, the other folks who manage the registration process and the website for us, and any of the staff from the Lockheed Martin Global Vision Center. Could you please just stand for a second? And I'd ask everybody to join me in a round of applause for everybody who helped out with it. Thanks very much, we really appreciate that. Now, our hosts, Lockheed Martin, have been most generous and helpful in a lot of ways. I'd like to invite you to take a tour of their display out there. The space experience is on the far side of the lobby over there. And Mr. David Brandt, who's standing in the back there, be happy to help organize a tour for you if you want to take a look through there anytime during the day if you want to walk out and do that. It's a great display, and if you haven't seen it before, it's well worth a look. And if you have other questions about the symposium or other things that are going on, feel free to find one of us who have one of these yellow staff tags on and ask us the questions. We're happy to help you out. Now, I have the honor of introducing our opening speaker. Mr. Jim Crocker is the Vice President and General Manager for Civil Space at the Lockheed Martin Space Systems Company. Mr. Crocker is responsible for his company's business that focuses on something near and dear to all of us, space science and planetary exploration, but also their human spaceflight programs now, mirroring the integration that's happening at NASA headquarters as well. He has a long and distinguished career in the space business, and I'd like to touch very briefly on 3 interesting points, I think, from his career. At the start of his career, of course, he graduated from Georgia Tech with a EE degree, which is impressive enough as it is. He designed electronics for scientific experiments in Skylab. He later led the team that developed the COSTAR instrument, which you can now see sitting in the Air and Space Museum in downtown DC there. That's the instrument that was used to correct the flawed optics on the Hubble Space Telescope. And just prior to joining Lockheed Martin, he served as program director for the Next Generation Space Telescope at Ball Aerospace. He's clearly a person who knows a thing or two about solar system exploration. In fact, Lockheed Martin's currently involved in the next 3 planetary missions that are going to fly Maven, OSIRIS-REx, and InSight. Lockheed Martin's the contractor on that. They're flying 4 missions, Juno, Grail, MRO, and Odyssey. Without any further ado, let me introduce Mr. Jim Crocker to talk to us about
Thanks for that great introduction, Bill. Well, good morning. Welcome to Lockheed Martin's Global Vision Center. We're really honored to have all of you here today. It's such a privilege for us to host this 50th anniversary celebration symposium on 50 years of planetary exploration in space. 50 years, half a century. You know, there's a lot of celebrations going on. If you walk around today and you see people with these little blue pins on, they're probably people who work for Lockheed Martin, because this year we're celebrating our 100th anniversary. On August 16th of 1912, in Los Angeles, California, in a small church building, Glenn L. Martin assembled his very first aircraft. Now, he did that at the encouragement of no less than Orville Wright, who said, you have a very interesting, innovative, maybe risky new design, but you really ought to go try this. He rented a church, he did that, he created something that to this day is not only an aircraft, but a great corporation. And 4 months later, 400 miles away, the two Lockheed brothers, who were great machinists, had in a garage started to assemble seaplanes which would start to set records for speed and distance. So a church and a garage. Many of the things that many of the startups now start in that we see in Silicon Valley. Just a couple of years ago, however, we had a 50th anniversary celebration of our own in Space Systems Company, because that's when both the Sunnyvale facility and the Denver facility were both brought online just a little over 50 years ago. And some people say that at least in Silicon Valley, it was the Lockheed Stanford. I mean, one time we had 30,000 scientists and engineers working in Sunnyvale that were really the underpinnings of Silicon Valley, and some of the great innovation that has come out in that area historians tell us, can be traced directly back to some of those investments and things that we made. You know, I was going to talk this morning and spend the 10 or 15 minutes that I have with you telling you about all of the great missions that Lockheed Martin has done over the last 50 years. Basically, the places we've been and the places we go are pretty amazing. You know, sometimes I talk to K through 12 children. I'm on the board of the Denver Museum of Nature and Science, and I can tell you there's two things that these kids get excited about, is dinosaurs and space exploration. Dinosaurs and rovers. I tell you, those are two really easy things to get kids excited about. So I was going to tell you about the 20 missions that we've done. As a matter of fact, this is already out of date because we just recently were selected to, with JPL, do the InSight mission. So I don't even have this talk updated for our latest mission. We've done 20 missions, or either done or on contract. We have 3 missions in the queue. We have 20 missions in total that we've done. But in addition to that, we have been honored to go with all of you, with the scientists, with NASA, to every planet in the solar system. Now, we can argue about Pluto, but that's another story. We talked about that a little last night. But, so we're going to the first Kuiper Belt object, having provided the Atlas that launched that spacecraft, and also providing the radioisotope system. So we have a list here of the missions that we've been involved in, and that's sort of playing in the background. It talks about our role and also about the exciting science that's been done for each of those. But I'm not going to talk about this morning, because last night I was motivated from a question that was asked in the audience over at the National Geographic's reception that we had, a question about why do we do this? I just said, okay, I'm going to throw this away because I think that this is more important. And as a matter of fact, these missions, they sell themselves. I mean, why do I need to tell you about this? All of us here will be extremely excited about all of these missions. So you can read the text in the background, because I think this is more important. I think we're at a time when re-energizing why we do this is so important. And I think all of us need to be thinking about, as the young science teacher last night asked the question, and I'll repeat the story. Matter of fact, I tried to catch him last night before he got away, but in the crowd I lost him. So if you're out there somewhere, please email me at james.h.crocker@gmail.com, because I'd like to hook up with you. He said that he's a science teacher. He got motivated to go into science because of all of the cool things that you do, all of us together do, in planetary and space exploration. And so he was driving along, and his wife said to him, he was telling her about Pluto and how cool it was with the New Horizons mission, and she said, well, why are we exploring space? And he said, I stopped the car and said, get out. I want to find out if he's still married or not. So I'd like to find out. But he's... I won't go there. So he said he was joking about telling his wife to get out of the car, but seriously, he said, what would be the 30-second speech that we would give to a politician to explain why we do this? And I ask you, what would not only be the 30-second speech that you would give, but what would be the longer conversation that you would have with a friend or with a student about why we do this? What would be that conversation? Now more than ever, is extremely important that we understand why we do this. Well, I can tell you why I do this, and it comes down to a couple of things. One thing was, when I was in the 3rd grade, my father bundled us up in a car, and he drove us to a museum, and in the museum was a Helicrafters, I would learn later, because I got into ham radio, shortwave radio. And there was a man named Billy McFadden who was a retired Navy radio operator who told us we were going to hear something amazing. And I thought, wow, what is this? There's warm tubes glowing on the Helicrafters radio. And I was kind of the youngest person there, I think, so he called me over and he put these big earphones on me. And he said, it's coming. Just a minute. Listen for it. And I heard the sounds of Sputnik. And it was space calling to me. I didn't know what a satellite was. I didn't understand it at the time, but I was hearing things from outer space. And it changed me. I wanted to learn about this stuff. I wanted and I knew math had something to do with it. I knew science had something to do with it, so I started learning about it. It was a few years later that in a backyard that my father drugged me to late one night, that I climbed up on a ladder and I looked through a 12-inch telescope that someone in our small town had built, and I saw the moon, and I saw the moons of Jupiter. And that was it just motivated me to go on and go into science and go into engineering. I can tell you that the young K through 12 people I talked to at the museum, at the Denver Museum, and at colleges and high schools and everything I go into, they don't go into taking the hard science, the hard math classes because they want to design a bridge that's 10% lighter, or a car that can get 2 miles more to the gallon, or a jet that can fly a little further. They go into these very hard things because someone instills in them the passion for what we do. Instill in someone the passion for what we do. Become a missionary for what we do, because I tell you, it can change this country. If you go back and you look at not people who are in the space program, but I'm in several alumni organizations, Johns Hopkins and Georgia Tech, University of Alabama and Huntsville, and when these kids come to different venues that I'm in, very few of them are in space, maybe 1 or 2%, but many of them design telecommunications electronics, they design computers, they design CAT scans, they design medical electronics, they design tele-operated surgical equipment. But when you ask them, why did you go into science and engineering? More often than not, they will tell you it's because I saw Neil Armstrong step onto the moon. I saw the pictures from Voyager come back. I saw, fill in the blank, something that had to do with space exploration that challenged them to do the very hard things that they had to do to go into these exciting, tough, hard fields. More often than not, it was motivated for science. It was motivated to go into science and engineering because of what you have done, what all of us have done together in planetary exploration. You know, I had the privilege 2 years ago, actually 1 year ago, of going to China with the U.S. Space Federation and seeing their space exploration program. It was really for me an eye-opener what was going on over there. They don't let me out a lot, especially in some countries, but this was a really great opportunity for me to go and see firsthand what the Chinese space program was doing. We got to go to both Beijing, to the Human Spaceflight Operations Center they have there, and also to Shanghai, where they build most of their weather satellites, and they actually had the Mars mission that would launch later on Phobos Grunt unsuccessfully because of a problem with the rocket. But they were really excited about going to Mars, I can tell you. As part of this trip, we went over to their equivalent, the Air and Space Museum, and it's starting to grow. They had their first capsule that they had flown their takonauts in. They had a model of their space station that they had launched just a year or so earlier. But I saw over in the corner a statue, and I thought, well, that's kind of strange. It kind of looks like something really old. And I thought, I wonder what that was. So I walked over there, and as I got closer, it dawned on me who the statue was of. If I tell you a little bit about it, I think a number of you in the audience will get it. It was a Chinese dignitary dressed in robes, basically sitting on what looked like a chair. He was holding two kites in his hand, but and I got it right away when I saw on the back there were clay models of hundreds and hundreds of skyrockets. Well, if you don't know who it is Whohas, and he was a minor diplomat in the 14th century who decided to go to the moon. And so he figured, well, you know, rockets had been invented, so you just put enough of them on the back of a chariot. And he did, and he got his servants to run up and light the fuses. And they lit all the fuses, and they ran back away. And there was this big explosion and cloud of dust, and he was gone. And they believe he got to the moon. Now, before you laugh too loudly, two things. One, there's a crater on the moon who's named in his honor. And half an hour later, the Chinese across the street docked their spacecraft with their space station, which they will tell you is on their path to the moon. The other thing I saw there was the step, the spring in the step, and the speed that the young engineers in China were moving. Now, most of them speak English, and so I had a conversation with a number of them, and I could tell you that there were some uncomfortable people while I was having these English conversations going on, but we were talking about why did you go into science and engineering? And I can tell you that they went into science and engineering because of what we did. They were incredibly jazzed about going to the moon. They were incredibly jazzed about going to Mars. They went in and did the hard science and engineering because they wanted to be part of exploration of the universe. That's why we do this. When I was in the 7th grade, I had a teacher who inspired me. I came from a small town, only 23,000 people at the time. And so Mrs. Johnson, my 7th grade teacher, was trying to put some culture in us kind of small town country boys. And she taught us, and girls, she taught us to enjoy some classical music, some Beethoven and some Chopin. And I thought that was kind of cool. And I've enjoyed that the rest of my life. But she showed us some art too. Art from different periods, and some of it I have to tell you I didn't care for, but there was one particularly that stuck in my mind. There's a Hubble Space Telescope image that kind of makes art come to life, and it's called Starry Nights. If you've ever seen the original by Vincent van Gogh, and you've also seen the Hubble image, they kind of merge together in my mind. But more importantly is a quote from Vincent van Gogh that says, "As for me, I don't know much, but when I look at the stars, I dream." So there's for dreaming today. I hope you enjoy this conversation that we're going to have today, but I hope you'll carry this conversation out, carry it to the Hill, carry it in the schools, carry it to your neighbors, carry it in people in this nation. It's important what we do, and it's important that we share the excitement and take them with us on this voyage. This is our voyage of discovery. This will be written about in the textbooks. It's what Magellan did. It's what Shackleton did. It's what all great explorers do. We're living in this time. Don't miss it. Enjoy today. Thank you.
Appreciate it.
Well, good morning, everybody. I'm Roger Lanius. I'm a senior curator at the National Air and Space Museum, and I've been engaged in space history for more than 20 years now. Some of that time at NASA headquarters as the chief historian. It's a pleasure to see all of you here. It's a pleasure to renew acquaintances with old friends and meet new folks that will become friends, I hope. And I can't think of a better way to start our formal presentations today than by inviting Peter Westwick up to come and give our opening keynote. Peter's at the University of Southern California, USC. He is a rising star in the history of science and technology. He's done 3 major books thus far, and I suspect we'll see more coming down the pike in the not too distant future. And he's over there going, well, maybe. Initially, he did a very fine book on the national labs. He followed that with an even better book from my perspective on JPL, the history of that since about 1980. And then finally, he has just published within the last year a book called, what is the title again? Blue Sky Metropolis. I don't know why I had a problem with that, but it deals with California and the aerospace community. Without further ado, let me invite Peter to come up and to open our presentations this morning with this keynote.
Okay, thank you, Roger, for the overly generous introduction. I would like to thank, I think all of us would like to thank the organizers of this great conference. Very interesting program coming up. Bill and Roger, of course, the NASA History and Science programs, the Air and Space Museum, Space History folks, JPL. Also like to thank Lockheed Martin for hosting us here. Over the past several months, I've been seeing these full-page ads in the Washington Post showing some of the fruits from Lockheed Martin's legacy project, showing the history of the company over the last 100 years. And it's good to see an aerospace firm recognizing the importance of history. I'd also like to thank Jim for the nice lead, and actually the question he asked, why do we do it, as you can tell from my title, is one of the concerns of my talk, with hopefully a little bit of historical perspective on why we have done it. So this past August, many of us were captivated by Curiosity landing on Mars, and I mean the spacecraft, not the human spirit of inquiry, although that was certainly present too. As all of you know, a lot was riding on the lander, on the landing, a $2 billion rover for starters, but also perhaps the national appetite for planetary exploration itself. Curiosity's success may have ensured that the U.S., at least, will continue to explore the solar system, so that the history we are called here to consider will continue. So we historians also thank JPL for some job security. About 50 years earlier, the Mariner 2 spacecraft skimmed 20,000 miles over Venus. Mariner and Curiosity bookend the 50 years that define this conference. In between, space explorers have met triumphant success and epic failure. They have seen ring spokes and blueberries, but also faces on Mars and great galactic ghouls. These 50 years of planetary exploration have taught us remarkable things about the solar system. They've also taught us a great deal about ourselves. We are gathered here to look outward to the other planets, and to contemplate all we have learned about them. But we will also drop our gaze back to Earth and consider what deep space exploration tells us about our own human history over the last 50 years. So our first question is, who has done it? Who are the explorers? By this I mean not the robots, but the people, institutions, and nations who built them. Let's start with the people. Who are these people? And what do they do all day? How have they changed over 50 years? And how has the work changed? What are their backgrounds? What do they do when they're not working? And how does that affect their work? As Glenn Asner pointed out a few years ago, after 50 years, we still need more social history of space exploration to understand what all these people were doing. We know a bit about the type of people involved. For starters, mostly men. Engineering and systems management was an overwhelmingly male preserve for most of the, well, at least the first half of this period. Now, women in the space program have been studied more in relation to the astronaut corps. Much remains to be done for planetary exploration. The number of women present in JPL's mission control for Curiosity was a marked contrast to all the men running Mariner. Still, though, the engineers on Curiosity are mostly male, and also mostly white. NASA has not had a sterling record of minority representation, although that, too, is changing recently. And as with gender, this ethnic representation is in part a reflection of the engineering profession at large in the United States, which has been changing over the last 50 years also. But nevertheless, even into the 1990s, this group of the planetary explorers themselves were, as Dan Golden so pungently put it, pale, male, and stale, as only Dan Golden could put it. One might also think about social classes. We mostly think about white-collar engineers and managers and neglect the many other people involved in the enterprise: machinists, security guards, secretaries, some of whom share the excitement of space exploration, but others of whom may not. I recall the JPL janitor who said the most exciting thing about the Viking landing was the large rat who ran across the floor and jumped into a trash can. There is also age demographics. The younger cohort that is filled in as the original space race generation retires has evidently brought a new sensibility to planetary missions, at least to judge by the Mohawks in Mission Control, not to mention the NASA And We Know It video you can all look up on YouTube. I recommend it if you haven't. Stale, they are not, although neither, we should remember, was the original generation back in the day. Next, what institutions explore the planets? Looking just at the US, we have universities, government labs, industrial corporations, for starters. Each type has different goals and cultures, and sometimes those things, those include things besides planetary exploration. How do university scientists interact with industry engineers? How does academic culture intersect the profit motive of contractors and the government demand for accountability? Consider JPL to take an example at random. JPL started as an Army rocket lab, and even after embracing planetary spacecraft as its main mission, JPL continued to work on military programs, at times substantial ones. These programs affected how JPL built planetary spacecraft, dating back to Ranger all the way forward to Faster, Better, Cheaper. And the relation between civil and military space was by no means static, nor confined to JPL. There's also much talk now about private industry and space exploration, the so-called alternative space movement, alt-space, new space, space 2.0, whatever you want to call it. Now, most public attention here has focused on the human spaceflight program, potential space tourism out in the Mojave, SpaceX ferrying supplies to the space station. But some private groups have tried to get into the planetary program, thinking back to AMSAT, the Planetary Society in the 80s, forward to Astrobotics and some of the other teams now competing for the Google Lunar X Prize. Okay, these institutions are just examples from the US. Now, that raises the question about which countries have done planetary exploration and why. For much of the last 50 years, it was mostly the US and Soviet Union, although more recently they've been joined by Europe, Japan, China, and India. We'll return to some of these countries in a moment. Let us first note, though, that our social and institutional history will provide a different picture in these different contexts, and that cross-national comparisons of, say, the type of people building spacecraft, their gender, ethnicity, social class, might be illuminating in some of these other places. For institutions, consider the bureaucratic politics of the Soviet Union, the Ministry of General Machine Building, or MOM, the IKI, Institute of Space Research, the various design bureaus and NPOs, and how these dynamics shaped the Soviet program. These differences include the relation between civil and military space. China, for example, may have had less distinction between civil and military space institutions, in part because they followed American suggestions back in the 70s to embrace the American model and integrate the two realms. Nations, of course, collaborated as well as competed in space, and space exploration has provided fertile ground for diplomatic or international history, looking at these international collaborations. Looking abroad has also raised interesting issues about colonialism. That is colonialism here on Earth, not space colonization. For example, the Soviets launching spacecraft out of what is now Kazakhstan, or the French launching rockets out of French Guyana. Consider also the far-flung tracking stations of the Deep Space Network, which confronted apartheid at the South Africa stations. How did such interactions affect the work? Okay, our second question, moving along fairly swiftly here, is how is it done? Planetary exploration, despite the title of this conference, is of course not just 50 years old. Astronomers and natural philosophers have been studying the planets for millennia. And planetary science is still done today by telescope from the ground. But I think when we talk about exploration, we're talking about going to the planets, not studying them from a distance. And that explains our focus here on the last 50 years. What's special about this period is the technology of rockets, which got humans and machines into outer space. Now, of course, there's the long-running debate about humans versus machines in the US space program. For this period, except for the moon, only robotic travelers have reached other planets. Now, how do we define exploration? What does exploring involve? Consider Herodotus, whom we call the father of history, and his tales of what he saw or heard on his travel, including such marvelous creatures as giant camel-eating ants and flying snakes. As Herodotus knew, it is not enough just to go somewhere new. We want to hear about what's there. You went to a new place? What did you see? So what is the record we expect to get back from other planets? It can't be a traveler's tale, so what is it? Numbers? That is, do we just go there and count things? Pictures? Physical samples? The answer to these questions helps determine the technologies deployed, such as cameras versus counters, as well as who is doing it, for instance, geologists or physicists. This affected spacecraft design, such as the showdown between spin-stabilized and three-axis stabilized, pitting fields and particles against imaging, physicists versus geologists, and Ames versus JPL. Several talks here will touch on this evolution of spacecraft technology, from orbiters to landers to rovers, Vidicons to CCDs, retro rocket landings to airbags and sky cranes, from flagship missions to faster, better, cheaper. One prime development of the last 50 years has been digital electronic computers. Spacecraft computers drove feedback loops of capability and complexity, and also, by the way, highlighted differences, for instance, between American and Soviet spacecraft. So American designers could change their software mid-flight, which allowed Mariner 9, for example, to wait out a dust storm on Mars. Meanwhile, its hardwired Soviet counterpart plunged fatally into the maelstrom. Later spacecraft pushed this flexibility toward the ideal of autonomy, though they have not taken the additional biomorphic step of replication urged by Freeman Dyson in the 80s, so we are still, alas, awaiting the promised profusion of astro chickens. But computer miniaturization did raise hopes about a proliferation of tiny spacecraft. Proposals from micro spacecraft dated to the late 1970s. Jim Burke, who was there, is here, I think. He's supposed to be here. His name is on, I think, the first proposal, at least that I've seen, for micro spacecraft. The motivation, as I understand it, was partly nostalgic, an attempt to return to the scale of the initial explorers. That's explorers with a capital E. Subsequent advances in nanotechnology spurred fantastic plans for, shoebox-sized spacecraft, with not only micro circuits but also microchined parts, these little micro rocket nozzles, reaction wheels, and the rest of it. These plans have not gotten off the ground. If anything, size seems to be going in the other direction, to judge from the Mars rovers. This seems an interesting path not taken. Why, after 30 years, are we still launching spacecraft the size of SUVs? This issue is partly technological, the problem of aperture being one constraint, but it is also programmatic, that is to say, political and cultural. Part of the appeal of micro spacecraft was the democratization of technology. You wouldn't need massive launch vehicles or massive budgets or big centralized projects. And yet planetary exploration remains, so far, a monopoly of nation states. In other words, how we do it reflects who does it. Computers, of course, were not just on spacecraft. They also had a role sitting on desktops here on Earth. This includes not just computers and spacecraft design, that is the front end of missions, but also on the back end, that is on data distribution and analysis. As computers drove data rates from 10 kilobits per second on Mariner to 100 kilobits on Voyager to 100 kilobytes on Galileo and ever upward, data management became as much a part of exploration as building spacecraft. Some planetary scientists may have little to do with spacecraft. They just sit at their computer and sift through these mountains of downloaded data. These desk-bound investigators may nevertheless also be explorers. While we're talking about technology and the front end and back end of missions, I would also urge us to recognize what we might call the middle. Specifically, the vital link between the spacecraft and the downloaded data, and that is the deep space network. Now, the DSN engineers aren't on TV when a spacecraft arrives at a distant planet, but they are crucial to getting it there and to hearing back from it. They have saved the bacon of spacecraft designers on several occasions, and they too deserve recognition as explorers. Now, how it was done was not just technologies, it was also techniques. We know about the emergence of systems engineering in the US, which was a discipline in several senses of the word. We also know that attitudes towards systems engineering changed over time, evident in philosophies like faster, better, cheaper, and total quality management. These techniques and attitudes can reveal much about particular places and times. For instance, in attitudes towards top-down control versus bottom-up individual creativity in planetary exploration. And again, who does it affects how it's done. Donna Shirley, for instance, perceived that the increasing presence of women at JPL was changing the practice of systems engineering. Finally, how do we do it suggests another basic question. The definition of exploration often has connotations of novelty. At what point does that term no longer apply to the planets? We no longer talk much about explorers on Earth, those intrepid souls who ventured across deserts and oceans or to mountain peaks and the poles. This does not mean there's nothing left on Earth to explore, far from it, but that we now think of this more as science than exploration. This is a loss. The urge to be first to a place, or at least first from your tribe, has inspired some of humankind's most remarkable achievements. Are we similarly losing the romantic appeal of space exploration? Consider the names of deep space missions. We have gone from Mariner, Ranger, Viking, Voyager, to Mars Polar Lander, Mars Climate Orbiter, Mars Science Laboratory. Romance gives way to practicality in many long-term relationships. This has programmatic implications. Do we revisit one planet, such as Mars, to extend our database, or do we continue to seek new places, comets or asteroids or outer planet satellites, for broader knowledge? And if we no longer have the romantic appeal of exploration, how do we inspire the amazing dedication of the people who build these spacecraft? Will they put in 100-hour weeks to launch yet another science lab to Mars? And how about the public? Will they lose interest when the novelty and romance of deep space travel wears off? Will familiarity breed contempt? And that leads us to our final question. Why do it? Now, there is, of course, curiosity. And here I do mean the human spirit of inquiry. And Jim, I think, gave a very eloquent testament to that spirit as a motivator. I would also add the fun factor for the engineers involved. Take the Mars rovers. Here is a marvelous technical challenge if you are an engineer. Take this car, deliver it 35 million miles to another planet, land it softly on the surface, and then drive it around. I mean, that sounds just like catnip if you're an engineer. Okay, so that's easy to understand. But why do we all pay these engineers to do these things? Over the past 50 years, NASA has spent somewhere around $50 billion exploring the planets, say a billion or so a year in constant dollars. And that number is very ballpark figure and depends on what you include in that in the budgets. $50 billion, though, give or take. There's also the investment of human resources, many thousands of highly trained and dedicated people with very valuable skills in the current economy. And that is just in the US. Add to that the many thousands more in other countries. So what did we get for this investment? Why do we do it? In 1970, a nun in Zambia named Sister Mary Yakunda wrote to NASA's Ernst Stuhlinger, as Roger knows this story, wrote to NASA's Ernst Stuhlinger asking how he could propose spending billions of dollars to explore Mars when children were starving here on Earth. Stuhlinger laid out several justifications which have become litany. The federal budget is broken up by agency and is not a zero-sum exercise, so that the money can't just be shifted to fight hunger or poverty. Understanding the other planets helps us understand climate, geology, meteorology, things like that here on Earth, which hence helps improve agriculture, fisheries, and so on. Space exploration highlights our common humanity and encourages international cooperation and thus reduces suffering from international strife. And if nations do compete, better for them to do so in outer space than in wars, then better to do so in outer space than through wars here on Earth. Space exploration inspires young people to pursue science and engineering, and their future discoveries will help humanity. And finally, the spin-off argument, new technologies that find applications here on Earth. Now, plenty of ink and bytes have been spilled rehearsing this debate, and the Curiosity landing seems to have revived it. You can look at this two ways. On the one hand, all those billions would pay for an awful lot of school textbooks or food for the poor. On the other, Curiosity costs less than what the Pentagon is spending every week in Afghanistan. Or insert your favorite comparison here. The current planetary program costs the equivalent of one Starbucks coffee for each American every year. Americans spend more on dog food every year, and so on. I'm sure you have equally amusing examples. But the fact is, $1 billion is a lot of money. I realize it might be a rounding error to some budgeteers, but to the average taxpayer, $1 billion seems like a lot. Leave aside the many other social priorities. What about scientific priorities? Genomics, particle physics, astronomy, material science. They could all do a lot with $1 billion. Or just think how many historians of science we could support with that. Now, polls consistently suggest over this time period that perhaps only 1/4 of the American public is interested in space, and even less are knowledgeable about it. But then, at planetary encounters, you have this tremendous public interest. Recall the media hordes who descended for Viking and Voyager, or tracked the web traffic for Pathfinder, MER, Curiosity. And let us not forget Carl Sagan, whose cosmos touched perhaps not billions and billions of people, but hundreds of millions of people around the world. But then why did none of the major TV networks break into their programming to show the Curiosity landing live? Now, NASA expends a lot of effort figuring out this paradox. How to bridge the apathy gap and sustain interest in exploration. I don't think this is just a matter of outreach. NASA has always been very attentive to PR, from the Mercury 7 and Apollo through Curiosity, and from Life magazine to TV and on to today's web-based social media and apps. Recall that JPL's first deep space proposals ranked public relations ahead of science or engineering goals. Or that Mariner 2 landed JPL director Bill Pickering on the cover of Time magazine and also on the Rose Parade. I actually saw one of these photos, was the Rose Parade with Bill Pickering and this Mariner float. But as Hans Mark declared decades ago at NASA, space missions apparently do not change how Americans vote. Space exploration certainly resonates with deep American values, and not least the frontier metaphor, and Americans take great pride in it. Last week, 1 million people lined the streets in LA. 1 million people in LA, that bastion of civic apathy, to watch a space shuttle crawl by at 2 miles an hour. Endeavour was only heading cross town, and not into outer space, and it was still a major public happening. The chief of the LAPD said he had never seen a crowd that was so positive and so proud. But when those same people step into the polling booth in 2 weeks, they won't pull the lever based on a candidate's space policy. This morning's poll will ponder the politics of space. This should, I think, include shifting ideologies of spaceflight, at least in the US. The early American space program received its initial support from politicians on the left, who saw it as the highest expression of socially directed technical progress. But in the late 60s, as liberals shifted federal attention to social problems, conservatives were abandoning fiscal austerity and embracing the vision of space as new frontier, as a way to rekindle that old pioneer spirit. So thus George Will, who is otherwise no friend of federal activity, viewed Voyager as a smashingly successful government program. Liberal commentators, for their part, came to view the frontier image as an emblem of imperial conquest, military adventure, environmental damage, and corporate profiteering. Hence, public opinion polls by the early 80s showed that conservatives were more likely than liberals to support space exploration. Now, some people extended the frontier image to space as a new realm for commerce. Capitalist ideology certainly animates the alt-space movement, but the profit motive seems largely absent from planetary exploration, which would be interesting for a major American enterprise, at least to a historian. Yes, there was excited talk about space mining and space solar power back in the 70s, and more recently there's the Google Lunar X Prize. But as a ploy to spur private investment, the X Prize seems an implicit admission that no marketplace exists for planetary exploration. So while many institutions have made money building spacecraft, some others may have lost it, the justification for those missions was not commercial. We have not launched these spacecraft to make money. Or so it seems. But in an age when, as historian Eric Hobsbawm declared, the consumer has taken the place of the citizen, can one so easily detach planetary exploration from the context of consumer capitalism, or late capitalism, as some commentators have called it? In this context, I look at will.i.am of the Black Eyed Peas, this lead singer of the Black Eyed Peas, who broadcast his latest single from Mars via Curiosity, and I wonder whether this is a sign of the times. Okay, this last point suggests that to answer the question of why we do it, we have to look at the broader context, at what else was happening over the last 50 years. For more than half that period, that was, of course, the Cold War. One reason the US supported planetary exploration for many years was to beat the Russians. In this case, in the battle for hearts and minds, for international status and prestige. This reason often rose and fell with the temperature of the Cold War. So you heard it often in the 60s, less so amid détente in the 70s, and then more again in the 80s when ambitious Soviet Mars proposals led to jokes about it indeed becoming the red planet. But then, of course, the Cold War ended. In the 90s, as the superpower standoff gave way to global competition in the high-tech economy, the justification for planetary exploration shifted from missions as symbols of international strategic standing to missions as engines of economic growth. Planetary exploration, in this argument, supported the high-tech space industry. It incubated new technologies and entrepreneurial firms, and perhaps most important, inspired young Americans to careers in science and technology, and hence helped supply the high-tech labor force. Now, perhaps to compensate for this mundane justification of economic competitiveness, the end of the Cold War also encouraged more transcendent motives, in particular, the possibility of life in the cosmos. The search for extraterrestrial life, in a way, turned planetary exploration into a biology program, which meshed with wider scientific and economic interest in biotech. Finally, however, one notes the many American flags waving around JPL's mission control, both for MER and more recently for Curiosity. Space exploration as a vehicle for national pride and patriotism was evidently not just a Cold War phenomenon. And that brings us to the motivation for other spacefaring countries. For Europe, it was perhaps less patriotism and more a way to foster European integration, while balancing American scientific and technological hegemony. In Europe, too, one sees economic competitiveness as a motive, and that is space missions as a stimulus or perhaps a subsidy for high-tech industry, and even stronger and earlier than in the US, and I think probably likewise for Japan. But national pride remains a powerful factor, especially for nations experiencing that other key development of the 20th century, post-colonialism. For a developing country like India, a space program symbolizes status as a modern, independent international power, much as nuclear weapons do. And let us not forget that civil space programs remain a barely veiled signal of military space capability. But in countries like India and China, where hundreds of millions of people struggle with desperate poverty despite pell-mell modernization, Sister Mary Yakunda's question remains acute. That is, how can these countries justify spending so much money on space? So the broad historical developments of the last 50 years, from the Cold War and post-colonialism to global economic development and high-tech industry, help answer why we've done it. The corollary, of course, is what have we got for it? Some people, like Stuhlinger, like to cite the spin-offs from space exploration. There are certainly many examples you can point to. Computer animation out of JPL, solar power technology, telecommunication coding algorithms from the DSN engineers. My personal favorite is the Super Soaker squirt gun, invented by a JPL engineer. So next time you're squirted by some kid on a summer day, thank JPL. But arguing that super soakers justify planetary exploration seems to me a thin reed. Justifying a program with spin-offs seems a tacit admission that the primary returns are not sufficient. And the primary returns alone, I think, should suffice. Consider what we have learned about our solar system. Ranger and Surveyor returned evidence that the moon had not always been cold and hard, although they could not resolve competing theories about lunar origin. Mariner flights confirmed Venus to be a hellhole of a planet with 900-degree temperatures and pressures 90 times greater than here on Earth. Mariner images of Mercury craters, meanwhile, supported the Great Bombardment theory of the early history of the solar system, which reinforced catastrophist theories of Earth's geological and biological history. Voyager and its successors Galileo and Cassini turned the outer planets and their moons from blurry smears on astronomers' plates to complex, diverse individual bodies, from the sulfurous calderas of Io to the icy ocean of Europa, each undergoing dynamic processes. External bombardment to the point of cracking or splitting entirely, or flexing gravitationally, outgassing and erupting, almost literally living and breathing. Planetary missions, in short, revealed the solar system to be full of marvels worthy of Herodotus. Methane lakes, miles-high geysers, supersonic winds, canyons thousands of miles long and several miles deep, volcanoes that dwarf Everest. They thus helped to correct the geocentric perspective of planetary scientists, evident, for example, in the surprise at volcanic and tectonic activity in the cold outer reaches of the solar system. More fundamental still is the possibility of extraterrestrial life, thanks to evidence of water on Mars, Europa, and Enceladus, and hydrocarbons on Titan. All this suggests that we shift our frame of reference. Perhaps it is not what we as individual taxpayers have got out of planetary exploration, but rather what we as a species have gained from it. And perhaps we need to shift our chronological frame of reference as well. Our frame of reference should span centuries, not just years or decades. Some see planetary exploration as a third age of human exploration, a fundamental turning point in human history, comparable to the oceanic voyages of Columbus and Cook in the 16th and 18th centuries. I would look rather to science. The physicist Niels Bohr said that science is the gradual removal of prejudices. If so, then planetary exploration would have to rank with the Copernican and Darwinian revolutions in removing the prejudices of geocentrism and anthropocentrism from humankind. Okay, the title of this talk asked 3 questions. Who did it, how they did it, and why? Let me wrap up here by adding a 4th. Why are we here? I mean, not in the existential sense, though planetary exploration certainly encourages such questions, but I mean rather, what are we doing in this room for the next 2 days? I said at the outset that 50 years of planetary exploration has taught us a lot about our solar system, but equally about ourselves here on Earth. What does planetary exploration tell us about the last 50 years of history? How does it change our view of the Cold War, of post-colonialism, of the information revolution, globalization, and economic development? Does planetary exploration change our periodization of, say, the space age or the Cold War? If the U.S. is indeed in imperial decline, or at least facing increasing strategic competition, how will that shape planetary exploration? I note that amid current confusion over American space goals, China recently announced an ambitious plan for soft lunar landers and sample returns. What about the nation state itself? Will the rise of transnational, multinational, sub-state, or non-state actors introduce new approaches? For one thing, it suggests that we historians find alternatives to the state-centered narratives that we usually use for the space age. Can we consider, following Martin Collins, how postmodernism affected the planetary enterprise? Perhaps, for instance, in the blurred boundary between high culture and low culture, or say, between elite science and mass entertainment. Think again of Will.i.am's broadcasting this piece of pop music from Curiosity, or I recall the Mattel Hot Wheels Sojourner action packs, which flew off toy store shelves in 1997, or Deep Impact, that is the movie, not the mission, which encouraged JPL managers at the time to contemplate what they called the merging of entertainment and realities. Historians of our topic should be pretty good at big pictures, since our frame of reference is the entire solar system. But we should remember to step back occasionally and think about the big historical picture, how planetary exploration connects to all these broader developments. Space history can be at times an insular field, despite the example of books like McDougall's, which show how space history can shed light on fundamental historical changes. And by tackling these broader questions, our work may speak not just to other space historians, but also reach out to historians in general, but also, more importantly, to the general public. And that, by the way, includes the need for, at times, critical voices. Many of us study this topic because we ourselves started out as space buffs, but we should include the viewpoints of the unbelievers. Planetary exploration, after all, is a human enterprise, and it thus reflects not just the great achievements of humankind, but also the very human foibles and failings. So yes, let us appreciate these remarkable achievements of space exploration, but let us also consider the costs. And let us also recognize that our topic runs up to the present, where the ice gets thin for historians. Times change, and so will historians' judgments. Sir Walter Raleigh, many years ago, warned that whosoever in writing a modern history should follow truth too near the heels, it may happily strike out his teeth. Or as Zhao Enlai supposedly said to Henry Kissinger when asked about the meaning of the French Revolution, it's too soon to tell. But let us begin. Thank you.
We have some time for questions. We would ask people to come to the microphones, and if there are any. If there are not, we'll take a break.
That's a good way to cut it off.
Okay. Bob Farquhar.
Don't think it's live.
Hello? Okay, now I got it. You mentioned a lot of different missions, but I noticed they were all from JPL. And since I'm one of the main competitors of JPL over the years, I'd like to hear about some of the other ones once in a while. APL has done a lot, and Goddard Space Flight Center has also done several.
I plead guilty on several counts here. First of all, well, I plead guilty, I guess, of talking about what I know best. So I've written a history of JPL, so I know mostly about that. I certainly did not mean to slight the competitors. I mentioned the Ames versus JPL standoff over the Pioneer versus the Mariner spacecraft models back in the 60s and 70s, what led into Galileo. Galileo being, I think, a remarkable example of this compromise between not only technologies and mission goals, but also institutions, I think, although JPL ended up building it. So yes, I did slight the many other competitors within NASA and without Goddard, but also places like APL. which is a very interesting story, I think especially in the 90s when APL starts to get into the game. I would also add to your criticism and say that I've not only concentrated on JPL, but I've also concentrated almost exclusively on the United States. And I think we have a lot to learn, let me just put it that way. We have a lot to learn from studying the histories of other planetary exploration programs. We know much more about, we still have a lot to learn about the American planetary exploration program, but compared to that, we know almost nothing about the Soviet program, the Chinese program, these other programs. And one of the things I'm looking forward to at this conference is they have assembled actually some very interesting papers on some of these other programs. So I'm looking forward to this conference of learning about some of these other programs, because I think these comparisons, international comparisons to these other countries, can shed a lot of light back on the American program, the institutions, the people who are doing it, the technologies deployed, and also this very fundamental reason of why they do it. How do they justify it to themselves, but also to the state and to the people of the state? So I can only plead guilty to, I didn't mean that by to neglect other institutions, but I just talked about what I knew best, and that's JPL. So you're absolutely right.
Hi, I'm Torrance Johnson from JPL. And one of the things I was struck by in your excellent talk was the intricacy of the web of ways in which we explore. Humans tend to make very linear things. You know, you're going to go someplace, fly by, then you're going to orbit, then you're going to land. But in fact, we've done all of those things in various mixtures. And it's interesting to contemplate that with respect to the exploration of our own Earth. I mean, we've had sample return ever since geologists and geochemists started looking at the Earth. We've had seismic stations for over a century. Yet some of the most exciting Earth science is being done by orbiters now, very sophisticated orbiters. We're doing the same sorts of things now with the moon that we've gone to many times. And one of the most exciting things I've seen recently are gravity maps from GRAIL. So I think it's a complex thing, and I think your talk brought that up very nicely.
Yeah, that's an excellent point. I guess the only thing I might add to that is that this might touch on this question of, you know, when does exploration end? And is there some point at which you're no longer exploring and the novelty wears off? Clearly, we're still exploring Earth. Maybe not so much in the public perception, but you know, the fact that we're still learning so much from these new perspectives suggests that will continue also for the moon and for the planets. I mean, the fact that we're still learning so much about the moon, new things about the moon, all these years after Apollo and the sample returns. So that suggests, you know, a partial answer to that part of my talk.
Ken Dillon, Ciencia Press. I wonder what you think of the parallel to what you're talking about, trying to use the space exploration or the solar system exploration, planetary exploration, to teach us about the history of the last 50 years. It can also teach us about other times in human history, and in particular, prehistory and ancient history. It can enlighten us. Things we discover on Mars now can enlighten us about what archaeoastronomy was about. And it can shed light on that most curious controversy from the past century, the one started by Immanuel Velikovsky, on which there's plenty of evidence, I think, that both sides, Velikovsky and his critics, had some very good points. So by exploring the planets, we're learning about ancient history, and conversely, by studying the ancient problems, astronomical problems and so on, that might point us in directions we can go today.
I think that's an excellent point. I'm not sure I have anything to add to it. I think I'll just take your point. Well put.
Hi, Jim Green from NASA headquarters. one thing I didn't quite hear from your talk is any opinion about whether you feel planetary science and its pursuit, solar system exploration, is essential for the survivability of the human race, not just intellectually, but even from a physical standpoint.
Yeah, that might actually follow. That was going to be my answer to the previous question, actually. And I had thought about talking about this in the talk, and for reasons of time, I cut it out. But it's a good question, and actually, I think Glenn is going to talk about precursors. And I think back to the 1970s, when things like the Club of Rome and Paul Ehrlich and others were talking about these Malthusian concerns, population explosion and population growth, resource scarcity, pollution, sparked these calls for space colonization. And the L5 Society and others were talking about going out that we need to escape, and also the prospect of nuclear Armageddon, but we need to escape Earth because of what we're doing to the planet. In order to ensure the survival of the human species, we need to go out and explore space, or we're not going to make it as a species. And that sparked calls not only for these human space colonies, but before you can do that, you need to go out and explore what's out there with robots. And that was used as a justification at the time, I think more by groups like L5, what we might think of as kind of on the fringes, than from NASA itself, although these fringe groups certainly, their ideas percolated in the mainstream. I have Gerard O'Neill has these fantastic plans for these space colonies. And I think this certainly ties into current talk about climate change. I don't think we've seen it too much, as far as I know, at the present, but I would look at this going forward with global warming and climate change, that we might see a return to these calls for space exploration as a way to, if we are indeed facing an end or constraints on our survival as a species here on Earth. And this goes back to the previous question, looking at records of the environment going back over the full span of human history and what this has meant for human civilizations in Mesopotamia, in the Indus River Valley, in the Yangtze River Valley. I've just been reading a marvelous book about this by Ian Morris, but talking about how environmental change has affected the rise and decline of human civilizations, that we might be in another such cycle now, and that this might actually maybe not at this particular moment, but in the very near future, provide another major justification for planetary exploration as a precursor to getting humans off the planet. So I think those two questions actually tie together very well.
All right. We need to draw to a close at this point. I'd like to thank everybody for participating in the discussion. Peter will be here through the conference, so you can certainly hit him up during breaks. And let's take one right now for about 5 minutes. And as we do so, the next panel needs to kind of get themselves ready.
Yeah, thanks, brother.
All right, hey, thanks. That's great.
Yeah.